Alright, this is part 2 of this video. I'll carry on from question 26. This is done for the Eunos Primary School Foundation Science Practice Set 1. So in part 1, we ended off at question 26 when I was explaining the answer for this. So the difference between the white fumes from the ice cream tub and the white fumes from the hot pot, well, we talk about the source of the water vapor. So the water vapor that condensed into the white fumes from the ice cream tub came from the surrounding air, while the other water vapor came from the hot pot. Okay, pardon my handwriting. My primary school teacher should have insisted on better handwriting from me. So anyway, after 30 minutes, Joseph observed that the ice cream melted and the soup turned cold. Explain why. This one is about heat transfer. So why did ice cream melt? Because the heat from the surroundings all went into the ice cream and melted the ice cream. Why did this become cold? The heat from the hot pot all went to the surroundings, leaving it cooler. So he observed this, explain why. So you can explain that heat was gained by the tub of ice cream, so it melted. This explains why ice cream melted. Next one, heat was lost by the soup, so it turned cold. Simple. You gain heat, well, it becomes hotter. In this case, the ice cream turned from solid to liquid, it melted. And for the soup, hot soup, it lost heat, so of course it turned cold. Right? Next one, question 27. Now, Lisa set up an experiment as shown in the diagram below. It's about light casting shadow on the screen. She placed an object P away from the torch and recorded the height of the shadow formed on the screen. Now this object, right, is something that can move. It moves nearer here, the shadow becomes actually larger. Move further away, shadow become shorter and smaller. So she repeated the experiment placing P at 15 cm. This is 10 cm, right? Then she placed it at 15 cm, which is here. Okay, then at 20 cm, which is here. So the further it placed, the height of the shadow actually became shorter and shorter. You see, the further, the height of the shadow became shorter. Even further, it became even shorter. How is the shadow formed? Very simple. You must see right now here. Am I casting a shadow here? Why? Because my hand is blocking the light that came from my windows. Right? So when anything blocks light, it casts a shadow. Even an object that is like transparent like this part, right? If it blocks light, it can also cast a shadow. You can see the bottom part here. Right? There's some shadow as well. There is faint shadow, but there's some shadow. This part is opaque, it blocks the shadow. This is translucent, sorry. It blocks more light, so the shadow is darker. So how does the shadow form? A shadow is formed when light is blocked. As simple as that. How does the distance between the torch and the object affect the height of the shadow form? This one asks you if you understood this table. So how did the distance between the torch and object, distance between the torch and the object, affect the height of the shadow? Height of the shadow form on the screen, So you see this one is getting further, right? This one is getting shorter. And that's all you need to know. So as the distance, you must copy the words inside, okay? Underline the words that you need to copy out. And then this part. So as the distance between the torch and P, right, here is actually increases, right? Increases. As that increases, what happened to the height? So now I use this next set of word, the height of the shadow, right? The height of the shadow formed on the screen This increasing or decreasing? Decreases. So the height of the shadow form on the screen decreases. Okay? As the distance between the torch and the P increases, the height of the shadows of the shadow form on the screen decreases. Using the same setup, which means using the same torch, same object, same screen, what should Lisa do to increase the height of the shadow form on the screen to more than 22 cm? I'm going to move this paper up here like this. Okay, so you can see the entire thing, the diagram in this. So if I want this height of the shadow to be more than 22, so you see this one is increasing, right? 15 is 20 cm between these two objects. 19 cm higher is now, I shorten the distance from 20 to 15. I make to make a larger, a higher shadow, I need to even narrow the distance some more. So if I want something that is more than 22, let's say 40 cm for example, what should I do to this distance? Should I increase it or decrease it? Of course I should decrease it. Okay? So here, what should she do? She should move object P even nearer to the torch. She should move object P even nearer to the torch. So I'll give you an example, right? Just to show you. So let's say this is the point of light. When object P is here, okay, it will cast a shadow about this high. See, light that shines here can't get through, right? Because it blocks light. Light that shines here can't get through, it blocks light. But if the object is, but light above it can shine. So on top here, you have no shadow. Light is just shining on this part, but this part is the shadow. What if now object P is here? Can you see? The object P is here. What will happen? Now, the light can only shine on the screen if it goes above. So in other words, anything below here, right, this object will block the light. Therefore, the shadow now suddenly becomes so much bigger. See? It's much taller. That's why moving the object nearer to the torch will increase the height of the shadow. Right, layer prepared the setup below. When the switch was closed, the magnet moved away 5 cm from the bar. It's an electromagnet. When you close the switch, it becomes a magnet. And then you notice it moved away. Moving away means there is a repulsion. If the repulsion means these two must be light poles. If this is north, this part must also be north and this should be south. So explain why magnet move bar XY, move away from bar XY. Alright, when the switch was closed, well, the magnet was repelled by the light pole on the electromagnet. Okay, it was repelled by the light pole. Of course, you can say it a different way. You can say that when the switch was closed, bar XY became an electromagnet, and point Y on the bar became the north pole of the magnet, which repelled the bar magnet. You can say it in different ways, but mainly you must say that this is an electromagnet and there's repulsion here, alright, and these two are light poles. Now, Layla wanted the magnet to move away less than 5 cm from bar XY. Less. If you want to move less, then this magnet must be a weaker electromagnet. So how to make it weaker? Most of the time you ask how to make it stronger. Now to make it weaker, very simple. You see there are many coils here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I make fewer coils, it becomes weaker. Also, there are 2 batteries here, right? I just remove one battery and it becomes weaker. Hold on a moment. Okay, so that's what we're going to do. So firstly, just reduce the number of coils around xy. This is xy. Next one, reduce the number of batteries. Last one, state the material bar xy made of magnetic material. Okay, sorry, you must state the material, right? You must state exactly what it is. So there are only two kinds of materials and magnetic material that you should learn. It's either tell me it's steel, you tell me it is iron. Either one of these is fine. Okay, magnetic material is a type of material. So that is a type. So this is state the material, you must give an example. So don't give the answer magnetic material, although if you write it down, there is some room to argue for marks for you, but give these two instead. Ramlee conducted an experiment in a dark room. He placed a plant in an enclosed glass container. Now this one is about photosynthesis, so I'm going to skip this part so we can reduce the time taken for correction. So this part, ignore this part for now, okay? Just ignore it. If you haven't done it yet, just leave it. If you have done it, just leave it also, okay? This question is also about photosynthesis, so ignore this, you don't have to do this. Yeah, that's it. All this is about photosynthesis question, and you're not required to know this year, but you're required to know this when you're at P6. Alright, so that's all for this video. Do remember to watch part 1 if you have not watched part 1 yet. All the best with your revision. I'll see you in the next video. Bye bye.